SwRI is simplifying robotics, bringing a user-friendly robot programming solution to a range of industries, manufacturing, retail, healthcare, and more. We'll explain how the SwRI Workbench for Offline Robotics Development, or SWORD, is making complex robotic systems more accessible and easier to use, and what that could mean for consumers and patients. That's next on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast, presented by Southwest Research Institute. From deep sea to deep space, we develop solutions to benefit humankind. Transcript and photos for this episode and all episodes are available at podcast.swri.org. Share the podcast and hit that subscribe button on your favorite podcast platform. Hello and welcome to Technology Today. I'm Lisa Pena. SwRI has developed a user-friendly robotics toolkit. So what does that mean? Let's think about manufacturing. Engineers and designers use computer-aided design software, or CAD, to create product models. Then they are forced out of familiar territory, shifting to other software to implement robotics for product assembly, to build their designs in the real world. The SwRI Workbench for Offline Robotics Development, or SWORD, cuts out the need for complicated robotic software and coding, working directly in CAD, a platform designed already know. This user-friendly solution for entry-level developers enables more people and industries to utilize advanced robotics. We'll talk about the potential impact to consumers and patients in a moment. Our guests today are SwRI SWORD developers Senior Program Manager Matt Robinson and Senior Research Engineer Michael Ripperger. Thank you for joining us, Matt and Michael.
Yeah, thanks, Lisa. It's good to be here.
Okay, so let's jump right into it. Many industries rely on automation and robotics for assembly and repetitive tasks to enhance safety and efficiency, but robotics setup can get complicated. So that's why you developed the SwRI Workbench for Offline Robotics Development, or SWORD, to simplify robotics programming. So tell us about SWORD. Give us an introduction to this new cutting-edge software.
Yep. So thanks, Lisa, again. So so in my role as the senior program manager, right, I steward the Ross Industrial project and the affiliated consortium, Ross Industrial, right? So which is based on the robot operating system ROS, middleware framework for robotics. That's gotten a lot of traction, not just in universities and academia, but also now in a lot of companies that are doing robotics professionally. And of course, we leverage those tools a lot here, and we help our clients leverage those tools as well. So in our engagement with our consortium membership and a lot of the stakeholders, they were always asking, like, hey, we love what we're seeing in this ROS ecosystem. We love what's going on in Ross Industrial. But like, man, we spend our day in CAD and these computer-aided design tools, right? We're working in SolidWorks, or CATIA comes up quite a bit. So they're very familiar with the CAD environment, what it looks like, how they interact with it. And their products they're working on are in CAD, and the systems on their shop floors and manufacturing factories are also in CAD. And like, it'd be great if we could like have these tools and have like ability to work with these tools in the system we're familiar with. And so that was sort of like one of the driving things to be like, there's all these different sort of like visualization tools coming around, but it was always like, hey, can we do this? Can we provide something in CAD? And that was sort of like where things got started.
All right. So it's saying people asking you, can you connect CAD with robotics? And the answer was a resounding, we can do that. So tell us, how did you go from CAD to making that bridge to SWORD?
Right. Yeah. So this is not particularly novel, I would say, right? There are a lot of CAD-esque, robotic softwares out there that are provided by the vendors of the robot arms themselves. And so, stuff like this has sort of been around, but the capabilities of a lot of those systems are pretty limited, especially when you start thinking about some of the advanced robotics capabilities, especially the things that we're doing here at SwRI. And so that was kind of where this idea came from, is like, hey, we've got these tools and they're not, quite up to what we think they ought to be able to do, right? How can we bake in some of the software that we're doing here kind of on the cutting edge of robotics development and put that in a CAD environment. So that's kind of where this idea came from.
As you describe it, SWORD is crashing the learning curve, providing a simpler way to get started with robotics. So how does it make robotics more accessible and easier to learn?
Yeah, right. So I guess I can represent that audience a little bit, right? Because I'm not a software developer by any means. I came up using industrial robotics the old-fashioned way, right, where we teach it point by point. And frankly, as Michael alluded to, right, there are tools out there that enable you to work in a CAD or CAD-like environment, but you're really just doing what you do with the controller, the control device for that industrial robot in your hand. You're just doing it at your desk. So it's still very much point by point. It's gotten a little better, but it's still relatively limited. We think about we use in like our casual settings with a lot of the people we work with is like it's that exciting YouTube content. When if a lot of us have seen the Boston Dynamics videos, for instance, right, where the robot's jumping around and doing parkour. I mean, right, there's a leap from, the people that are just getting into robotics to that, like, say, really neat YouTube capability we see, right? So what can we do to enable folks that are, like, say, getting into robotics, they are CAD savvy and good. They know their traditional industrial robotics systems, but they're not really ready to go full on C++, manipulating point clouds, like, under the hood, like these things that Michael and his team do all the time, right? But like, can we give them some sort of like a springboard, right, to kind of get there and start like experimenting with these robots that almost program themselves. So no more point-to-point program, but setting up what we call motion planning, where the system can say, understand what's going on in its environment, and I can resolve and make these motions without, like, say, having to do like the point-by-point program, which was the old way of doing it. And that acceleration, or getting people to the point where they can start seeing the real value of when we say advanced capability, i.e. things like autonomous motion planning, then they'll continue to like improve their own skills. But they have that nice starting point that meets them where they are. And I think that's what's been really exciting about where SWORD has gotten.
Okay, let's talk about motion planning for a minute, since you mentioned it quite a bit. So describe it for me. What is a scenario in which motion planning comes into play?
Yeah, I'd say for just, any sort of industrial application, be it like sanding or grinding, right? You have a part and you have some points on that part where you need to take a tool like a grinder or a sander or a paint gun. You need to move over your part and do some sort of task, right? And so you've got these points that exist sort of in 3D space on your part, but then you need to figure out, how does the robot need to move its joints such that it takes that tool and performs a process that you care about? And that's what we're calling motion planning, is this process of figuring out how you move your robot to do a task, while also thinking about all sorts of other different things, like, how do I not run into anything and cause a crash? How do I sort of be optimal with the amount of time it takes me to do that, or some other process constraints to, like, how fast and how smoothly do I need to move? All that sort of stuff gets kind of encapsulated in what we call motion planning. And that's kind of a huge chunk of what SWORD is wrapping in these advanced capabilities of new developments that we've made around this motion planning capability, especially when you start thinking about very complicated systems, not just 6 degree of freedom robots, but like robots on rails or robots on gantries or robots with tools that have joints and things that can move. At that point, it becomes really, really complicated to program these robots kind of with your own brain, with the tools that already exist. It's just very complicated, and that's where some of these capabilities really can provide a big impact, I think.
So you're programming those robots to know their way around the tools, the environment, the product, whatever it may be, and to do it all without collision, without crashing.
Exactly.
All right, great. So one of its main selling points, one of its main capabilities is that motion planning, but let's go through some of SWORD's other key capabilities. What does it do?
Yeah, so I think kind of at the root level, like when you start using SWORD, one of the capabilities we have is just building an environment to begin with, right? So we generally have a lot of parts and things in CAD, but ultimately we kind of have to assemble those together into what the workspace actually looks like. And from sort of the robot programming perspective, it's beneficial to kind of treat what the robot looks like, visually, to how some of these algorithms think about them for collision checking and collision avoidance. And so we baked a lot of tools there about how do you set up this environment such that it's sort of compatible with the back-end tools, but still kind of looks like CAD. and then building in these tools to kind of transform the geometry of your robot and your environment into things that are sort of more efficient and more effective for the actual tools themselves.
Tell me about this intuitive graphical interface.
Yeah. So, Matt was talking a little bit earlier about, crashing this learning curve for people who aren't roboticists. But I think a big problem for people who actually are roboticists, too, is that a lot of these tools don't even come with like some visual front end. It's just a lot of code and a lot of concepts, and you kind of have to fit that in your brain and sort of understand how that works. And that's just kind of limiting for everybody, right? And even if you're a really smart person, it's very tough to kind of get all that in your brain. And so, what we mean by that is just essentially wrapping these tools in a thing that you can interact with and see with your own eyes. You have a 3D environment, you can move it around, you can kind of look at things, inspect things, you can make changes, perform some sort of task and see how did your change impact what just happened. A lot of that stuff just doesn't really even exist in the tool set that we have. A lot of it is just code, and you run a program and a bunch of numbers come out and you have to kind of interpret what that means. But what we're trying to do here with SWORD is put a kind of a graphical front end on it where you can actually see things in 3D and kind of make a connection with what you're doing physically a little bit better.
Okay, so let me know if I'm understanding this correctly. So let's take something simple like a paint stroke. We want that robot to make an upwards paint stroke. So before, you just have to know the code for that. And I don't know if that's a series of slashes, letters, numbers, whatever it is. You'd have to know it. But now with the SWORD toolkit, you might be able to just click on paint upstroke, paint stroke, something like that.
Yeah.
Is that what we're talking about?
I think like a good metaphor, like when I think of like the graphical user interface relative to motion planning in particular, I tend to think of it as like almost like building a flow chart, right? So if you've done any kind of like project and you want to lay it out, like you have like, oh, when I reach this point, I'm going to behave this way. And like, oh, if that doesn't work, fall back here. And like, you have like the little decision diamond, yes, no. And you're actually able to kind of set up those motion plans and like, I want to use this function. No, it didn't work, right? So pivot back to this function, right? So the motion planning, the optimization component works very much like that. You can set up these like, say, flow diagrams for your process. And then, like as Michael said, you can graphically change how they're connected or drop in a new box and then run it and kind of see what looks a little different.
The way you're describing it makes me feel like I could program a robot right now. So it sounds very empowering and user-friendly, as you said. So let's talk about, who is using SWORD. You said high-end users to entry level. So
yeah, that's obviously the vision, right? But I think, it was interesting, this is born out of IR, internal research here at SwRI, right? So we had like a parallel value proposition. And one of the neat ideas is that like, hey, anytime we go to set up and do a project, we as well have to spend this time like setting up the environment as Michael describes it, and we're like all excited about the new problem we're going to solve. Like, well, wait, we've got to do all of this environment building and I've got to get my 5 software tools and a bunch of configuration files. And so ideally what's been interesting is obviously some level of internal adoption and using this tool to help us work more efficiently. So if you're already like, say, very familiar with like a lot of the different tools and you're using like, say, the ROS-based ecosystem or just advanced motion planning tools, like SWORD is a benefit to you because you can get to that fun stuff a little bit sooner, right? And maybe a lot sooner, right? And so that is actually part of the value proposition is that we do our work more efficiently as well, right? And then, of course, the neat knockoff of there is like in parallel, we make improvements that other folks can as well. Now, I came from industry, right? I worked at Caterpillar for like 13 years and did a lot of manufacturing engineering. And so we know, and we have partners who have adopted SWORD the exact same way where I came from, like my team. And we were like very comfortable with like, say, the OEM provided software tools or some of the other offline programming tools of yore. But like we're wanting to get like, so to like, set ourselves up to take advantage of these advanced tools. And that's that springboard piece where we could start actually being dangerous without having to go get our online graduate degree in computer science. So that's been really nice. And of course, obviously we have, if you will, peers outside of SwRI that we collaborate with who are also interested in using SWORD, right? We get like really great positive feedback, right? And sometimes very public settings, which is nice. That's like the free advertisement we like. And so like those different communities have kind of come together providing feedback. And obviously we're just hence we're here, right? We're also trying to drive awareness that this tool is out there, and we're happy to support it. And we're using it to make our lives a little easier too.
I was going to add too that I think there's a lot of value for students as well. So especially college students, right? You're maybe doing a robotics degree or engineering degree, and you want to use robotics, right? The learning curve is just huge, right? If you're a mechanical engineer like me, right, you kind of have to go bootstrap and learn like how do you even write code to begin with. And I think those students can have a pretty good grasp on like the concepts of robotics, but like going into the nitty gritty is really pretty hard at that level. So I think SWORD can kind of help address some of that too, and more of like a learning perspective where it's like, hey, we want to go do stuff with robotics, but let's start with this tool where I can really kind of help teach you the concepts. You can see, hey, if I change these different parameters, how does stuff change, and get a real good feel at the high level for how robotics works. And once you're there, kind of then dive into some of the code. So I think there's value there also for kind of students at that level.
I think Michael brings up a great point, right? And I think one of the most rewarding things about working, like, say, here and in this team and being at SwRI is like, we don't just like, you could call me up and I could deliver you robot X, right? But the cool thing is that like we teach who we deliver to, right? So they become more self-sufficient over the course of the collaboration, right? It's not just us dropping the keys off. We can work that way, but I think it's obviously rewarding for our clients as well as for our teams when we collaborate together. And we've had the benefit, due to a number of different programs, to work closely with university partners. And so getting feedback, enabling them to use SWORD, there's a real nice, because they're the developers and the solution providers of tomorrow, right? So giving them the tools to accelerate how they can contribute. And we're now seeing more undergrads. So we have one university partner in particular. Their core focus is like, hey, we want to onboard undergrads, because this ROS and advanced robotics stuff, air quotes, has typically been the domain of grad students largely, right? And so it's been neat to hear positive feedback about SWORD relative to accelerating even undergrads getting involved. And of course, eventually we're hearing now more of high schoolers even starting to poke around at some of these advanced tools, and that's exciting to see.
Yeah, really, really cool. You're not just, as you said, dropping off the robot, you're also sharing your knowledge and skills with these developers of tomorrow. So I wanted to talk about ROS a little bit. You have already mentioned it a couple of times, but to get a full picture of SWORD's capabilities, we should understand the Robot Operating System, or ROS. And Matt, you told us about ROS on episode 2. That was way back in 2018, so it's been a while. Definitely time for a refresher. So give us a quick overview. What is ROS? How does it work?
Right. And to be clear, right, SWORD is able to be utilized without ROS, but it complements the ROS framework as well. So the Robot Operating System, it's a robotics middleware framework. It's been around since the early 2010s-ish, right? They had their 10-year anniversary now almost 5 or 6 years ago. And so it's basically become very much a standard, if you will. They don't refer to it as a standard, but a standard, if you will, for kind of next generation robotics application development. And it's open source. It comes with a lot of baked in plumbing and tools to send all the sensor data around and the different motion planning kind of things that are happening. And it comes also with a really big user community. And it is open source, right? So people can make contributions. They can introspect what is already out there. They can bring it in its business-friendly license, so you can bring things in and modify it to meet your needs. And that's all really compelling, right? And it drives a lot of really great interaction and knowledge sharing as a community. Now, ROS's scope is really big, right? From everything to like, drones to hobby to, all kinds of things, underwater. Where obviously here we support the add-on, or if you will, extension of ROS into industrial use cases. And that's the program we steward here at SwRI and collaborate with a couple international partners on, ROS Industrial. And the consortium helps keep it going. And so there we're really focused on providing specific tools to really make ROS, or leverage the good things that ROS brings to the table in industrial settings and applications, and leveraging industrial relevant hardware. So you hear us mention the robot quite a bit. So those tools have been out in the industrial manufacturing space for a long time. And so sometimes marrying like old school known tools to like modern computer science tools. Well, that's why Ross Industrial exists. And that's been a fun journey. And we collaborate both with the people who provide technology to industrial factories and industrial settings, as well as like, bridging it to this little bit more, let's just say, advanced robotics community and more software developer community. It's been great to kind of merge those two together and kind of sit in the middle. And that's a little bit what we're doing, leveraging ROS in an industrial context and how we're trying to provide some tools to enable the industrial community that's used to CAD participate more effectively.
Okay, so tell us about the link between ROS and SWORD. How does a SWORD user leverage everything available in ROS?
Yeah, that's a good question. So I'd say, a lot of the capabilities that we're baking into SWORD sort of existed in this ROS ecosystem beforehand. They're things that we've been working on or things that were in the ecosystem that we had been utilizing. And, from my developer perspective, again, like a lot of these tools don't have great front ends. And so you really have to go read some code and read the papers behind how these things work to sort of understand how you're supposed to use them. And it's very hard to kind of tune their performance and actually see what's going on, right? And so I think we're essentially taking some of those tools, pulling them in, and then trying to kind of bridge that gap that says, okay, here's a nice visual way to see what these different algorithms are doing, provide you the little places where you can tune it, and then give you the ability to kind of see how your changes affect the output of what these algorithms are doing.
Let's look ahead. What industries could potentially benefit from SWORD? What are you thinking?
Yeah, I think industries that deal with high mix, low volume production are probably the closest targets here, right? So like aerospace, we're working a lot with steel foundries now, people who produce only a small number of parts before they have to go sort of change something about the part and redo all their robotics, right? So right now with traditional robotics, that's just really hard because you got to spend a lot of time kind of manually doing all of your programming and making sure that everything is just perfect in your robot cell. And as soon as any of that changes, then you got to go through that whole effort. So anybody whose sort of manufacturing operations look like that, I think would be a really great target for sort of adoption of SWORD now.
I can go on and on, right? We're seeing obviously more robotics enter like the kind of consumer space, right? Where the robot is being asked to work on something that is from a regular person on the street. And that could be a number of different things, but it's inherently low lot, high mix, right? So as Michael alluded to, SWORD aligns well with enabling those types of applications. We're seeing more and more with high mix paint, right? I have this arbitrary thing that shows up. I want to paint it. Cleaning has come up quite a bit across all sectors. And in food processing, similarly, right? So we're seeing a lot of their interest in food. And there's a lot of interesting opportunities there as well. Regardless of, like, say, the domain, the general flavor is, hey, I'm not making 10,000 of the same thing over and over again, right? So I need new solutions and new ways to kind of enable, to leverage the benefits of automation and robotics. It could be safety, it could be velocity, quality, typically all three. But I can't. There's just not enough Michael Rippergers to get this off the ground, right? So how can my team do this?
Okay, and I want to go a little further. So help us visualize a few more possibilities. How would SWORD be used in, let's say, an agricultural setting?
Well, I mentioned food, right? So you can imagine anytime I have, like, say, like robotic material handling situations where conceivably things are coming off the field, right? And I'm in, like, so to speak, like some sort of building, or maybe I want to move pallets around of a produce that has been recently picked and then, like, obviously sorted. SWORD could be really useful in setting up that environment, that handling environment, to enable that autonomous fork truck or like some other robots that are handling things off conveyors. As the pallets come in, they then typically will conveyor something to sort, to pick the good berry and get the leaves off. SWORD would shine there in getting that sort of thing set up. Obviously, food products coming out of the field are inherently high mix, right? Like the one berry is really big, the other berry is small. Another really interesting one is mushrooms. I didn't know this about mushrooms, but apparently they change by the hour. Right. Wow. So, and then there's really discrete strategies about like, say, cutting this mushroom to enable the other mushrooms to grow bigger, and of course check back in 2 hours because then they'll be ready to go. And so SWORD is really a useful tool, again, to set up those sorts of environments too. They're rapidly changing. Anything that's sort of low, high mix, right? So agriculture has a lot of those elements, with the added, of course, benefit of dirt, dust, maybe sun if you go outside, which is just other robotics challenges. But
I want to do this a couple more times. Okay, so let's think about retail. How could SWORD help us in the retail space?
I think again, they all have this similar thread. You can imagine, like, let's take our average, big box store, right? You can pick your flavor. They're going to have aisles, right? They're going to have these things I don't want the robot to run into. So all that, like, setting up, that's the environment we talk about setting up, right? So I also like potentially want to, like, say, come up with plans if I'm doing let's say shelf restocking, right? Which is a very common task we hear about in retail, or even just doing inventory checking, right? So there's that motion planning element of like, oh, I've got to put the thing on the shelf, but like, what do I do if like there's already like it's half full? What if it's only 1/4 full? What if the products from the neighboring slot are slid over? That's where Michael talks about iterating on the motion planning, right? So those are sort of the tangible, let's just say 1-for-1 type of retail use case scenarios you could envision in a SWORD context.
All right, one more. Let's go to healthcare. What do you envision with SWORD and in the healthcare space?
Yeah, I again. It would depend on the use case, but like one of the common ones we get, and again, it's like more backroom operations for now. So you don't always see it. But like it's typically, we had one with like the sortation of so they'll receive like big packages of like, say, like Band-Aids or whatever, right? Like these things that they're consumables to support all the patients. And they'll come in sort of a back room and then need to be broken down and sorted into smaller batches to go to the various wards or operational areas. These are like very similar to warehouse logistics problems or operating a plant, and all the same challenges, right? Like, so I have like, I got to make these smaller batches out of like big batches. I have an environment. I have, potentially people are entering. I have these like zones where I don't necessarily want to, I want to avoid entirely that might be virtually represented. We do a lot of that. And so again, that's the environment creation piece, because like I have high mix, like maybe I'm making smaller batches of like, say, gauze, Band-Aids, whatever. I may set up some motion planning scenarios to sort through those. And I can do a lot of like, say, means testing virtually before I try to actually drop it in there where people are coming and going. And that's, again, SWORD will hopefully accelerate that timeline.
Yeah, I think that's kind of like the biggest piece for me as well, kind of from the developer side, is that, once you have your sort of nominal environment set up, like there's a very long process of testing and tuning and getting all the things right before you get on hardware. And it would be really, really nice to be able to do that in sort of simulation with a lot of things that are sort of easily changeable by the user at their desk, so you can kind of plan out all these different scenarios and make sure that, the application that you're building is going to work when you go and deploy it. And so I think that's kind of the big gap that SWORD fills in my mind, at least for the developer perspective, is, you can use SWORD to do this and kind of play around, or you can jump straight to hardware and spend much, much more time dealing with all hardware issues and like potentially wrecking your robot and destroying some other things. That's like, something you probably don't want to do. And so I think that, usually you don't want to do that, right?
All right. So you did touch on this, but how would consumers, patients, the public benefit from industry implementing SWORD?
Yeah, I think it's, again, there's a big interest in our circles about this notion of virtual commissioning. But as Michael talked about from the developer experience, it's like, I want to like work out as many kinks as possible before I put it on hardware. I think one of the big things we talk about in like, say, like general community adoption or being comfortable with robotics in our spaces, right? You talked about retail and obviously my kids love it. Like when we go to like a college campus and they got the robot delivery robots and they put the googly eyes on them. Like my kids are like almost like robot natives, if you will, right? We talk about tech natives. SWORD is a tool, if used properly, in a number of these simulation tools, right? But ideally, because SWORD, we're trying to bring it to where the engineers are in CAD. Ideally, these tools enable both a greater timeline to see value in delivering the solution. So that's a return, which makes more investment happen. But then obviously, because of like, as Michael described, the kind of testing that can happen, we can get on hardware more efficiently, and then we've done more testing. So then those people walking around, potentially these robots, whether they have googly eyes or not, can feel safe around them. Like they don't have to be scared of the robot. And I think, we talk about what are some of the barriers and just like robots getting in homes and things like that. It's because like, I don't know, like this robot that can potentially punch through a wall. Like I don't necessarily want it next to me, like trying to chef up my dinner.
Yeah, no.
Right. So, all we can do to understand the behavior, introspect and like test behavior. And that's another thing we talk about in the robotics circles, right? I need deterministic behavior or behavior that's intuitive and it looks and feels natural to me when I'm around this system. That's why we put robots in cages, right? Because it's not always, right? And the robot can be dangerous. So whatever we can do to provide tools to enable people to get to a solution that exhibits proper behavior and it's bankable and the kinks are out, that's good.
All right. And again, education, knowledge, sharing those skills is so important for your team. SwRI will be offering a SWORD boot camp and training. Is this available now? And how can someone sign up if it is? And when does this all start?
So yeah, Michael's put on a couple workshops already. It's sort of ad hoc. We're going to be featuring SWORD at Automate, which is the week of May 12th. And so we'll have some stand-up kind of intro workshops to SWORD while we're there at our booth at Automate in Detroit. But then, of course, like we'll be broadcasting different workshops. We typically try to attach them to other, say, Ross Industrial or other SwRI Intelligent Systems Division events. So stay tuned. We publish those on our different communications channels as they pop up.
All right. And SwRI does have an events page. So watch the SwRI events tab up at the top of our main homepage to get more information on SWORD and Ross Industrial trainings and workshops coming up. And there is a website that'll tell you all about all things SWORD.
Yeah. So there's a dedicated webpage to support SWORD. It's sword.swri.org. And so we are trying to, you can request the demo version and experiment with yourself. And we're trying to also get the information up there to understand like when the workshops are. And of course, you can request a quote for if you're interested in purchasing. sword.swri.org for all things SWORD. That's
all right,
it.
Thanks. You did mention Automate. You will be showcasing SWORD in Detroit, as you said, May 12th through 15th at the upcoming Automate conference. It's one of the largest robotics and automations events in the world. So what do you have planned for Automate?
Oh, man.
Yeah, so I think we're going to have a booth with a robot set up next to SWORD and let you kind of come up and program a robot to do a somewhat complex task relatively quickly and then deploy it straight to the robot and actually see your work functioning on a real robot.
It's always nice to have a real robot in the booth.
All right.
It's a real people draw.
Yeah, I would think so. And as you said, you'll be giving a rundown of how it all works.
Correct. I mean, the working theory is that we'll hey, you want to learn more about SWORD? We're going to do a walkthrough like at 2:00. So it'll be somewhat organic. It'll be kind of like stand up, pop up. Mike will say a few things, or he'll probably be the driver. I'm happy to say a few things too. I have no problem talking. But historically, then obviously both historically and obviously we feature SWORD where we can sort of organically as well. So for instance, we're working out a couple other sort of like kind of collaborative social gatherings like in the evenings of that week, in which case we'll both mention and highlight SWORD to people in our, let's just say, advanced robotics community that also happens to go to Automate. Because that advanced robotics community is a thinner slice of the Automate crowd. I mean, because Automate draws, your very person who's never put a robot in their factory before to obviously startups and people doing like really interesting advanced work, as well as some academics. So sometimes we'll cordon off like a little special time, like one of the evenings, and have a gathering, in which case we could be like, hey, SWORD, we have a trial version. Feel free to check it out, right? And those groups are typically ready to this whole environment stuff's painful, and like we got a solution for you.
It's all right here.
Right. So those things sort of happen organically, believe it or not, even though Automate's such a big show. And of course, we have our Ross Industrial annual meeting on the 15th specifically, and that's always a great time. I'll be mentioning SWORD to that particular audience. So our consortium is obviously driven the CAD portion of that to a certain degree. And so we've had members uptake already, right? So we've got a number of seats out there in our members' hands, and we're going to continue to let them know how it's moving forward and hopefully gain some more traction that way.
All right. So if you are in the automation and robotics world and you are planning to go to Automate in Detroit, May 12th through 15th, stop by the SwRI booth to learn all about SWORD and Ross Industrial and so much more. All right. So SWORD is one of your latest developments, but the SwRI Robotics and Automation team is always looking ahead, planning for the future. So what robotics challenges are you tackling next?
We're working a lot on robotics for space applications. So that's pretty exciting. There may be some room for SWORD in that space as well. But yeah, trying to deploy robots in space to do manufacturing, to repair satellites, to do sort of autonomous operations on the moon or other planets, things like that. Yeah,
that's a great one. I think another thing that's been really interesting lately is we've been doing mobile robots in this group for a long time. Right. So there's been lots of interesting R&D 100 awards and obviously featured projects around, the laser ablation robot work that's happened here in the group. But what's been interesting lately is we've taken some of these advanced robotics tools we've talked about and we've adapted them to wheeled bases to enable what we call basically coordinated motion between like a robot arm on a wheeled base. Without a bunch of external measuring and tracking. So it enables things like complex painting over long distances, welding, sealing, anything where you need to do a continuous process while the robot's driving along. Historically, you've either had to gantry those types of applications, like i.e. put a bunch of infrastructure and rails and so the robot can travel around a big volume, or you've had to have expensive metrology to kind of track all the pieces. So this has been, so to speak, it's in the weeds, but it's enabling a new class of applications at way lower deployment cost and way more flexibility for the end user. We're doing some really fun work with handling large bulky items, and sometimes those large bulky items aren't always rigid. And so that's a lot of the real low-level control work for handling things, and that's been really neat. If you think about how our arms work, like managing a big piece of wood, right? Making that happen across multiple robot arms is tricky. And it's been some really fun work. And we got some, I think, new information coming out on SwRI communication channels soon on that work.
All right. Always an exciting time with the SwRI Robotics team. It was great to learn about SWORD today and your motivation for developing it to meet people where they already work in software they already know to make robotics more accessible. And again, that has the potential to streamline processes in so many industries. So congratulations on your outstanding work. And thank you both for joining us today.
Yeah, thanks for having us.
Thanks, Lisa.
And thank you to our listeners for learning along with us today. You can hear all Technology Today episodes and see photos and complete transcripts at podcast.swri.org. Remember to share our podcast and subscribe on your favorite podcast platform. Want to see what else we're up to? Connect with Southwest Research Institute on Facebook, Instagram, X, LinkedIn, and YouTube. Check out the Technology Today magazine at technologytoday.swri.org. And now is a great time to become an SwRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Pena. Thanks for listening.